Alrighty. So problem number 5 on your Math 108 sample final states draw the graph of y equals 4 sine of x over 3. Show at least 2 full cycles. So essentially, these are the materials that you need to solve the problem. So the first thing is that you need to know the basic sine and cosine curves. So the first one, the one on the upper right, is y equals sine of x from 0 to 2 pi. And notice the pattern of the sine curve. It starts with an intercept, it goes to a maximum, followed by an intercept, then a minimum, and intercept. Okay, so that's essentially the 5 key points for one cycle of y equals sine of x. Another thing that you need is if it asks you about the cosine curve, the cosine curve pattern from 0 to 2 pi is a little bit different. The 5 key points goes as maximum, intercept, minimum, followed by intercept, maximum. Okay, so once you know the basic sine or cosine curves, the next thing you have to do is identify the amplitude, or we call it the frequency. So in short, the amplitude is always the absolute value of A, and it produces the range for us. So the range will be from negative A to A. Essentially, that is the value that is in front of the sine or cosine function. Now, to determine the length of exactly one cycle, we call that the period. And the formula says that your length of each cycle will be 2 pi divided by b, where b is the coefficient usually attached to your x. Then you scale the x-axis, by the way, by a length of period over 4. So if you take the length of each cycle and divide it by 4, it essentially gives you the location of where the 5 key points will be, okay? And then lastly, you sketch 2 full cycles. So let's see how this works for the sample final question. Here again, it says, draw the graph of y equals 4 sine of x over 3. Show at least 2 full cycles. So let's first figure out the amplitude. So for the amplitude, you need to take the absolute value of A. So in this case, you're taking the absolute value of 4, which is? No. Absolute value of 4. No. 4. The absolute value of 4 is going to be 4. So this gives you your range. So what the amplitude allows us to do is scale the y-axis. It gives us the range. The range will be from negative 4 to positive 4. All right. Now we have the amplitude. You now figure out the period. So the period we say is 2 pi divided by b. So what do you think would be the value of b in this problem? No. So 4 was the value of A, okay? The value of B, careful, the value of B is the coefficient of X. But look at this. You have X over 3. Is there another way that I could rewrite X over 3? Hello. Is there another way that I could rewrite X over 3? The answer is yes. Instead of saying that you have X over 3, you can say that you have 1/3 of X. By rewriting X over 3 as 1/3 of X, this helps you to figure out the B value. B is now clearly 1/3, okay? So if you want to figure out the period, you do 2 pi times the reciprocal of 1/3, which is 3. So 2 pi times 3 is 6 pi. So what this means is that you will have the first cycle goes from 0 to 6 pi, and your second cycle will go from, I believe, 6 pi to 12 pi. because again, the period gives you the length of your cycle. All right, now there's one more thing I need, and this one more thing that I need is just to help me scale the x-axis. If I take the value of the period and divide it by 4, right? We're taking 6 pi and divide this by 4. You can reduce this fraction, right? A number that goes into 6 and 4 evenly is 2. So you could rewrite this as 3 pi over 2. So this will be the way that I'm going to scale the x-axis, right? So now let me just draw the x and y-axis for us. So here's our y-axis. Here's our x-axis. Now, the first cycle, well, let me just scale out the y-axis. So the intersection will be the origin, 0. We have a maximum value of 4 and a minimum value of -4. On the x-axis, I'm going to go by multiples of 3 pi over 2. So if I start with 0, the next value would be 3 pi over 2. The next value, if I add another 3 pi over 2, would be 6 pi over 2. So you can leave it as 6 pi over 2 because you can recognize that 6 pi over 2 is just 3 pi. If I add another 3 pi over 2, this is going to be 9 pi over 2. And now we have 12 pi over 2. So that very first cycle starts at 0, and it goes all the way up to 12 pi over 2, which is precisely 6 pi. Then I repeat the process. For my second cycle, you start at 6 pi, and we're going to end at 12 pi. So this one would be 15 pi over 2. Then 18 pi over 2, which is 9 pi. Then you have 21 pi over 2. And then lastly, 24 pi over 2 is going to be my 12 pi. So in green, that interval that I highlight here in green, that's going to be our second cycle. The one in red will be the interval for the first cycle. All right. So now remember, we're dealing with the sine function. So the way that sine works is it begins always, well, if you plug in 0, it begins with an intercept. So the first point that we have is an intercept. At 3 pi over 2, it's a maximum. So it goes to 4. At 6 pi over 2, it's a intercept. At 9 pi over 2, it's -4. And at 12 pi over 2, it's going to be an intercept. So I can connect those points with a smooth curve, or try to at least connect them with a smooth curve. So that's my first cycle. Now I just repeat the process. We start with an intercept at 12 pi over 2 or 6 pi. At 15 pi over 2, we're going to have back a maximum again. At 18 pi over 2, it's an intercept. At 21 pi over 2, it's a minimum. And then 24 pi over 2, it's an intercept. And now you connect the second set of points with another smooth curve, at least what I'm trying to do here. And you get your second cycle. And now this would represent the graph of y equals 4 sine of x over 3. Again, know the pattern for the sine function. The 5 key points goes as intercept, maximum, intercept, minimum, intercept. For cosine, it's the other way. It's not really the other way. For cosine, it goes as maximum, intercept, minimum, intercept, max. Okay? All right? So that is the solution to problem 5.